Hello, good morning, and welcome to the DevOps Career Workshop. I'm going to talk about a number of things in this video about where you are on your journey and the skills that you need that make up the whole DevOps landscape. I use DevOps in a very loose term here. It's the mixture of two things after all, portmanteau if you will, between the developers and operations. Traditionally, operations looked after all the infrastructure, particularly in production, and developers are never allowed to go anywhere near production. And then there's the developers, the people that write the software, that test the software, that ultimately are in charge of what really goes well and what really goes badly. And these two mixtures of types have now come together in DevOps. And DevOps has moved on again since then, where we come with the platform. So as software as a service has gained popularity, we now have a platform that hosts that software as a service. So entire companies are software as a service and they run a platform. People like Facebook. And Facebook's got people in there that are a mixture of developers, graphic designers, UI people specialists, and infrastructure sitting in there as well. And we can throw another term into the mix. You build it, you run it. This is where, essentially, if you're the one that's written the software and deployed that software to the infrastructure, then you should know how to run that software. All the little nitpick things in there, that extra knowledge that makes you special at what you're doing, and not throwing it over the wall to somebody who's never seen the software ever before. It took them 3 hours to deploy it, and then they panic and have to roll back. Very old way of doing it. We want to roll forward, we want to fix forward, we want to work together, and we want to have that breadth of skills where not only we can write software, if we so choose, we know how to deploy it, and we know how to support it. And we're allowed to. If anything, DevOps is about breaking down silos, about those gaps in between the departments within a company that were largely there due to company stuff. Anyway, let's get into it. Need to find my window a minute. Somewhere around here. Here we go. Okay, so where are you on the journey? I know there's a lot of people that are quite new to this field, and so, where do you start? What does the path ahead look like? And so, where do you start at the beginning? If you're lucky enough, like me, I had my break as an apprentice. They didn't call me an apprentice back then. I was called a trainee technician. But the emphasis is the same. You can be an apprentice for 0 to 2 years. This is where you're getting quite a good understanding of the breadth of everything that you need to know to be a great DevOps engineer, or a great platform, or a great IT contractor. Those foundations are important. And whilst you might not have a deep understanding of any of the areas, any great level, you understand how all the jigsaw puzzle fits together. You can see the big view, and you can kind of dabble in areas and be helpful and useful and learn things in those 2 years. After 2 years, you may go on to engineer level. This is where you're gaining a deeper understanding, maybe even specializing in 1 or 2 of the areas. And so over those next 3 years, you've got the room to expand your skills, expand your knowledge, work in more than one of those areas. I'll come on to the areas in a minute. And then when you feel up to it, when you're ready to make that leap as senior engineer, what do those look like? But first, a little bit about me. Who am I? Well, I'm an IT contractor. I specialize in DevOps. I'd call myself a DevOps expert. And I started programming as a teenager in my room on a ZX Spectrum. And that was quite a special time where you build those core level of skills. And so I always wanted to be a programmer. My dreams were automating everything and being able to help the world be more efficient. Anyway, that's a bit lofty. So I got my first break in IT in 1995. And as I said before, this was as an IT technician and a trainee technician. Programmers for 2 years, just like an apprenticeship. And then after that, get promoted to a full technician. Now I'm saying technician here because in my experience, I started off on the hardware side. Even though I was programming as a teenager, my break was in hardware. But that's handy because that set me up for the ops side and already had an interest in the dev side. So when DevOps finally became a thing in 2015, blimey Charlie, it was my best job in the world. That was exactly what I was looking for all along. And so doing it as a contractor is even more profitable. But we'll come on to contracting later. So as an apprentice, as I said, you're learning the fundamentals, all the various bits and bobs that make up the DevOps and programming and operations and infrastructure landscape. As an engineer, you're mastering the tools, mastering the fundamentals, mastering automation, because you don't then tend to get into automation right at the beginning. You need to understand how to do it manually first before you can automate it. As IBM once said, you can't automate a process that doesn't exist. And in master scaling, one of the big advantages of DevOps and automation is then we couple that with cloud infrastructure. And the unique benefit of cloud infrastructure, apart from being able to spend your money really quickly, is related to that, is being able to scale automatically. Now we're only talking about the hardware side. The software, that needs a little bit more consideration when it comes to scaling. Not much, but a little bit. And scaling to meet the demand is all about understanding how that stuff scales. Now we've seen some disasters on scaling as well. I'm sure many of you remember COVID, it's still with us. But right at the beginning, online shopping went crazy. And as a result, a lot of online retailers had a real big difficulty with fulfilling just the website, never mind the back orders and that stuff as well. And that was largely because they weren't ready for scaling. The scaling's tricky, and as an engineer, you can master that. And then senior engineer. This is where we're talking about the platform. Mastering the platform is being able to sit on any of the functions on that platform, whether you're a developer or whether you're helping other developers, or the infrastructure or telemetry, build and deploy. We'll come on to those in a moment. And as a senior engineer, you've got more than 6 years experience. So some organizations are a bit more structured than others, but if you're anything like me, I like to share my knowledge, especially with the apprentices. Help them get into the spirit of things. They've got all that excitement, all that potential, and I love to see that grow and flourish. And as a senior engineer, you've got the option to go contracting. You've got that seasoned experience. Why not get paid for it? So here's the areas that we're talking about today. We've got developer support, telemetry, security, platform admin and tools, build and deploy, infrastructure, and environments. So, as an apprentice, what should you look at? Well, looking at virtualization is kind of one of the base things you need to know in this world. When I started out back in 1995, a long time ago, virtualization didn't really exist. It was all about physical stuff, understanding physical servers, how to rack them, how to build them. Building them has not changed much. But understanding the physical infrastructure, which is something that the cloud providers handle for us and we don't really need to worry about anymore. Of course, if want to run your own cloud, then it's important that you should know that. If you're running VMware, then you probably understand there's going to be some hardware that needs to run on. If it's in-house, your in-house data centers, that kind of thing, then focusing on that hardware is going to be important. But these days, virtualization, how does that work? You can set up at home. You might even run VirtualBox on your local machine. It's just another way of splitting up resources and creating a server. So then on to the next thing of infrastructure as code. The flexibility, if you will, of the cloud providers does give us that sprawl, if you like. And so infrastructure as code is being able to define it in a very specific way. Mainly so that when something goes wrong, we've got documentation already. What should it look like? Well, we know we've got it in the infrastructure as code. That's what it should look like. In practice, it means we can run that infrastructure as code over and over again just to assert what the infrastructure should look like. And if anything's in there that shouldn't be, then that should highlight straight away. But infrastructure as code does more than that. It allows us to really define what we want, how many servers there should be, auto-scaling groups in the case of scaling, as well as being able to define other areas, the stuff that gets put together, networking, load balancers, all that kind of thing. How do these all interact? And having it as infrastructure as code also starts to touch on the programming side. I'm thinking specifically about Terraform here. I wouldn't describe Terraform as a programming language, but it's kind of got the makings of one. Closely coupled with that is configuration management. Once you've told a cloud provider like AWS that you want an EC2 instance, you'll get an image. Now, Amazon have loads of images that you can choose from. And most people will pick a base image based on an operating system like Ubuntu, CentOS. But on its own, that server doesn't do very much. Great, you're paying a load of money to look at a console, SSH into. In order to give that server a workload, this is where configuration management comes in. Something like Puppet or Ansible. You can tell the infrastructure that when it boots up, it should become a web server. The next thing to do is to tell it what a web server looks like to you. So by having an Ansible runbook, the server instantly knows what you know about a web server. It can boot up, it can pick up that Ansible playbook, it can run through that playbook, and now it looks like a web server as you've described it. Of course, Ansible can do lots of other things apart from just running playbooks, but that's where the apprentice level is expanding their knowledge through the configuration management. Programming. You can't automate anything without knowing a bit about programming. In a very minimal level of programming, like Logo, don't know if that's still a thing. Let me describe what Logo was quickly. For those that don't know, it's a very basic language that could control a robot that had a pen in it. And by having, I think it's about 4 commands, I think it's similar to Scratch in that respect. You can have pen up and pen down, whether you want to draw or not. And then the rest are controlling the direction of the robot, so it can go forward or backwards, and it can turn on the spot. So by being able to do those actions, you can describe a picture. It's almost like a vector description. And I think in Scratch you can do this where it will link up to a physical robot if you want to with your Raspberry Pi or whatever. You can also emulate it on the screen. Anyway, whilst you've got commands sitting in the middle, what programming's really about is setting up variables, comparisons, and jumping through code based on functions. And those fundamentals are necessary so you can understand programming and help with the automation piece, which is the other major factor in all of the areas across DevOps and platform engineering. Tightly coupled with the programming is source code. Now, if you're just running it on your machine, it doesn't matter. But what if your machine breaks? You have a backup. The other way of doing it is having a source code program like Git. And these are useful because they can give you not only a structure and a backup of where to store something, but it enables you to look at the history of what you've done. And it marks who did it. I mean, in a team, this can be a little bit embarrassing sometimes. I know I'm not the only one to say that I've looked at some code in my team and thought, who the heck wrote that? And then I look through the source control and find it was me 6 months ago. And that just proves that we're all improving every day. How to do things better. You know, there's a great deal of difference between the code you write now and the code you wrote 6 months ago. Now imagine that times 10. The code you wrote 5 years ago versus the code you wrote today. Some of mine's out there on the internet, and it's truly shocking. But there you go. Everyone's learning all the time, even me. And then we got CI/CD, continuous integration and continuous deployment. This is where we're doing automation. The programming and the source control comes into its own with the CI/CD. We're telling it to do stuff in an automated manner based on an input. So if we're talking about continuous deployment, this could be closely tied with a thing called GitOps. GitOps is where something happens to the Git repository in the source control, and then that triggers a sequence of events, usually in a CI/CD server like Jenkins or GitHub Actions, where we can maybe build the software, test the software, and then deploy the software. And then bringing this all together, this workflow, like Scrum or Kanban. This is a way of breaking down tasks. And it's very much an agile way of doing things. So there's two main ways of doing things. There's the project management or waterfall way of doing things. And that's where you might see something like a Gantt chart that says, we're going to do this, then we're going to do this, then we're going to do this, then we're going to do this. And the whole thing's going to take 12 months, and then you'll have a fully working thing, Mr. Customer. And for some things, that works really well. You know, building houses, where it's all very done before, templated. If you're working on a new project, though, like a new house or a new block, you know, a unique building like the Gherkin, then that may or may not work. You might not be able to predict all of the difficulties you're going to find, all the information you're going to learn on that journey. And so this is where the Agile Manifesto comes into things. You can Google that, Agile Manifesto. But this is where it's more agile. You don't necessarily come up with a 12-month plan ahead. You maybe come up with a 2-week plan in the terms of Scrum. If you're running in 2-week sprints, and then you can get your jobs defined, what we're going to achieve in the next 2 weeks. That's a much easier time frame in order to tell the future in. Much more confined, much more smaller. And so in a sprint, you'll define that we're going to achieve this, this, and this, and we're going to do these tasks within the next 2 weeks. And you might find that you finish all of those tasks within 9 days and you've got a spare day on the end. Maybe. You're lucky. Other times, you'll have 2 or 3 tasks left over, and those can be planned into the next 2-week sprint. I wouldn't say the opposite of that, but another way of working is Kanban. Now, Kanban is quite literally a giant to-do list where Rather than having a 2-week sprint plan, you don't have a sprint at all. You just pick up whatever's at the top of the prioritized list, work on that, complete it, do a demo and stuff, of course, to share with the rest of your team, and then pick up onto the next task. And you can have checkpoints and things to make sure that you are getting on well with, you're supposed to be getting on with stakeholders and things like that. So that's kind of touching on all of the workflow stuff of things. So let's move up to engineering. What do we do at the engineer level? We might recall earlier I said we're mastering the platform, we're mastering the tools. And so here's the tools that quite often need mastering. Of course, you would have seen all of these in the apprentice step. It's about mastering them, understanding more, having that experience. Working with Vagrant and Docker for the virtualization piece. Terraform for the infrastructure as code. Packer kind of sits in the middle, and that's where you can define an image. And we get the whole argument of whether you should bake in or not bake in. What I mean by that is you can start off with the OS image, like I mentioned earlier, with Packer. Then you can build stuff on top of that base image. Many organizations do this for like a golden image that contains all of the stuff common to their platform. So every single server, regardless of what it is, if it's a database server or an email server, web server, they all have shared components that sit on top of that, that act as the foundation. Stuff like logging. All the logs are going to go to a central location because we don't really want to log on to the box every time in order to see the logs, and we can just go to a central location and search and use that power in order to find what we're looking for really quickly. And so that login information, the configuration, maybe just the software, but not the configuration. You want to keep your code and business logic separate. Keep the data out the code. It's just a good thing to do, because then if your data gets leaked, that's really bad. But if your code gets leaked, problem. So you're reducing your security footprint. There's lots of other reasons why you want to keep the two separate as well. Anyway, we got Packer. We're running with CentOS. We've got our basic logging software on there, like maybe Logstash or something like that. And we create an image. And then we use that image later on when we spin up the rest of the infrastructure. It gives it less to do on startup. We want to have a server starting up as quickly as we can. And this is where the bake-in or not bake-in comes into it. We could have an image that's got all the stuff baked in about web software, and then all we have to do on boot up is just plug in the data. Stuff like what's the server called? What load balancer is it in? That kind of thing. The alternative to that is to not bake it in. So we boot the web server up using our golden image, which just has the login, the software on it at this point. And then we use something like Ansible in order to load more software. So we're running Nginx or Apache. It needs to download and load that onto the server and then configure it with the data. Whereas with the baked in, all we're doing with Ansible is we're just baking in the data. So the boot time can be less, but the maintenance is more because you've got more images to look after. So there's a balance with everything. And that's where the experience of mastering the tools comes into finding where that balance is. So programming, I mentioned that on the apprentice slide, and yeah, starting with something like Scratch is quite simple, quite graphical. But you want to get on to working in an IDE, an integrated development environment, as quickly as you can. And so something like Python programming is quite a varied and versatile language. It's been around for absolutely years, almost as long as Ruby, Perl, quite as long as Perl. Anyway, it's quite a robust and easy to learn language, I think. I cut my teeth on machine code and basic. That's quite a hard slog. You have to have lots of enthusiasm to get through that. Python's not quite as hard as that. So yeah, if you know Python, great, learn more of it. If you don't know Python, yeah, get into Python, I would recommend. And then the last two tools we've got on here, Git. Lots of Git command line foo that you could learn, like rebasing or cherry picking, sorts of stuff. You can go a long way with Git outside of the push, pull, and commit commands. And then Jenkins, just as an example of a CI/CD server that's extremely popular in the market. I mean, there are others. Thinking of some now. GoCD or Concourse or something like that. And then there's the software as a service ones as well, you know, Code Build and Git Actions, GitLab, and there's loads. So mastering one, knowing a couple, depends on your customer or project ultimately. But there's a lot of Jenkins out there, so if you had to pick one, I would learn Jenkins first. So engineering, mastering the fundamentals, stuff like DevOps and SRE. Can I remember what SRE stands for? No. It kind of came along as another term sort of to replace DevOps that focuses more on the infrastructure side of things, like reliability and things. If you do know what that stands for, and because I haven't looked it up right now, put it in the comments just to help everyone else out. That'd be cool. And then operability came along, you know, an operability engineer, which kind of sounds more inclusive. Yeah, operability is about helping systems and people talk to each other. And in far of our areas, you know, our platform team, there's lots of different things talking to each other. On build and deploy, you might be taking a GitOps action from something like GitHub or GitLab, and then that comes into an API that then logs something over to your logging system, and then talks to the build system to actually action the creation of that build or act on whatever that commit was. So lots of interactions, APIs, interoperability, and knowing that as an engineer, you can add a lot of value, and mastering those moves you that step up. Mastering automation. So talking about the tools that we've mentioned, but using them in an automated way. So imagine the Terraform, tie that in with GitOps. So you've committed something into a repository that has Terraform code that then triggers off a build and deployment of that new Terraform code. And it's just a little step, but that gets you started on the automation thing. And the big one as far as platform engineering, and this is very on the fashion, on the subject right now, is self-service portals. So another reason why the cloud operators like Amazon, like Azure, blown up really quickly is because they provide self-service. You don't have to raise a ticket with somebody at Amazon to say, hello, can I order a server please, and then fill in a form and then wait for that server to be delivered. No, you can just go into the console and say, click, I want a server. It then shows you the form. Click, 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 go. Bang, you've got a server. Self-service. You haven't had to involve anybody at Amazon. They're doing lots of stuff. I've heard the thing that says in a data center they're installing at least one rack a day because of the amount of growth that they're getting. And so they've got people on the ground that are wheeling the servers in, plugging them all in, and switching the whole rack on. A whole rack can hold something like 40 servers, even more if they're using blades. I don't know exactly what their technology is. I've never been in one of their data centers. It's a very privileged position. So you don't have to worry about that because you've got self-service on their portal. That's the only bit you have to interact with. And so as a platform engineer, we want to provide that level of service to our customers. So the developers, if they just want to create a new job, they don't have to raise a ticket with us and say, oh, we'd like a new job on Jenkins, whatever. They either have access to Jenkins directly to create their own jobs, or they have some sort of GitOps that creates the jobs for them. And master scaling. So Amazon, for instance, provide capacity planners, or capacity providers, I should say. Capacity planning, that's related, I suppose. But no, capacity provider is an automated scaling thing, where if you have an auto scaling group, you can normally provide a minimum and a maximum and some rules as to how it can scale. Whereas a capacity provider kind of takes that to the next level, where if you're using something like container management service, you want to use EC2 servers rather than Fargate, then a capacity provider can then control the number of instances that are generated in order to run those containers for you. Sort of like an AAP, only a little bit more aware of the services that's running. But one of the difficulties of scaling is scaling down. How do you know when a server is not doing anything useful? Scale down. You don't want to have a server suddenly switch off when it's halfway through a request, because that annoys people, starters, but you might lose data, something like that. And so mastering scaling and scaling down is quite a tricky thing to do, and there's lots of things to learn in that area to make sure that that doesn't cause disruption. And balancing the cost versus the performance. There's always the option of scaling up. Someone said to me today, I want to do a mass deployment, and at the moment the limit is 50. Why can't we have 100? And I said, well, you can have 100 if you like, but you know that if you're doing 50 at the same time, it's going to take a bit longer than if you do 100 at the same time. But spinning up 100 at the same time costs you twice as much money. Whereas if you're slotting it into the capacity that you already have, you're kind of already paying for that as a baseline. It doesn't cost any extra. It just means that you're waiting longer. Now there's a balance there between how long do you get somebody who's being paid, how long they have to wait, versus paying extra cost for the servers in order to do their thing. So there's a balance to be had there too. Anyway, engineers. So I focused very much on platform and DevOps and stuff, but there's also machine learning and artificial intelligence. They're platforms too. And so there's different tools that you need to understand that are more important. Starting off with software as a service. If it's your website, you've got your 3-tier application. The 3 tiers being the front end, the business logic, and the database. And that's quite a thing to get hold of and understand. But then going to the next level is the artificial intelligence and machine learning platforms, where it's still kind of the same. You've still got that front end, the business logic, or the what would you call it? Kind of the processes that do the stuff, the computing power. And then you've got the data stores, but rather than databases, you might have HDFS, which is like a distributed disk file system. So when you're talking about machine learning and artificial intelligence, it's much more about data, and we're talking lots of data. If you're not talking petabytes of data, that's not a lot of data. I was speaking to somebody where they said, "Oh, we've got a terabyte of data and we'd like to analyze it." And I says, "Great, just go spin up a server and go analyze it." Like, oh, I thought it was more complicated than that. It's like, well, no, not really. When you're talking about a terabyte, that's nothing. When you talk about hundreds of petabytes of data, then you need to understand how to distribute that data so that multiple compute nodes can then work on that data at the same time. Otherwise, you're talking that balance between time waiting and time spending. Scale up and distribute it, because it could be the difference between analyzing it in a week or analyzing it in a year. So yeah, it's a different platform. There's different tools, and there's different computing and understandings of thing. I mean, the fundamentals are still the same. So if you've started over on your SaaS product, that's good. We've still got compute power, we've still got the databases or the data, and we've still got the scaling and up and the down and the automation. They're just different and take it to another level. And so this then opens us up to the senior engineer. And IT never stays still. There's always something else coming along, always something new to learn. In my career, all the way from 95, we've had, in 97, 98, started off virtualization, some basic containers and stuff around 99. And then that turned into more virtualization, like the KVM hypervisors and things around 99, 2000, 2001. And that's when Amazon was born as a web service, 2001. And so then going from hardware to virtual hardware, virtualization, to then having cloud providers, to then having DevOps, to then having platforms, to then having artificial intelligence and machine learning. Now those things have always existed to a degree, but they just get bigger and more popular and current thing. And so IT never stays still, and DevOps and cloud engineer space is no different to that. So it's about keeping up to date and mastering platform engineering and mastering the platform. And so I mentioned the platform again. Let's bring this slide back about the areas: developer support, security, telemetry, platform admin and tools, build and deploy, and infrastructure and environments. And they're all important, but all different in their same way. Telemetry is all about keeping the logs and the metrics available, so you can build a dashboard or you can build alerts. And when you get an alert, you want to go, well, why did we get that alert? So you've got that historical data of the metrics, so you can see how well it's going. Touches on capacity planning, perhaps, maybe. Or when something breaks, you want to go back into the logs and see how that developed. Is there any information in the logs that can help you isolate what the fault was? Moving over to infrastructure and environments, we're talking about having the basic infrastructure to run stuff. I mean, servers, they're kind of easy in this sense, but yeah, infrastructure environments will build a server image, that base server image that I talked about, that might even provide some extra images on top of that. If you've got some standard code that does a Jenkins server, they might provide that, or standard code for a web server, they might provide that, and various tools then to make the other teams a bit more efficient, because they haven't got to do it either. They then work a bit closely, I guess, with the platform admin. So platform admin is a strange description. It kind of plugs in all the gaps. It's about the tooling and things. Illustrate it with an example, like who on this diagram will help a new starter with a GitHub account? Well, the new starter can self-serve and get their own GitHub account, but then that GitHub account needs access to the repositories. And so it's the platform admin that then provides that access. Same for if they want an email account. Infrastructure might look after the email server, but platform admin will then provide access to that email server. So I think hopefully that explains it. Security is kind of a specialist, a subject matter expertise. They help all of the other areas understand and consider security issues as they're designing and building out new functionality. Whether they're talking to developers about keeping the applications secure, or they're talking to infrastructure about making sure that the network is secure, or they're talking to telemetry to make sure that logs are secure and not leaking any sensitive information. And build and deploy, keeping all of that side of things secure as well. So keeping security at the forefront of everyone else's mind, and acting as a sounding post, or like I said, a subject matter expert to help people answer any questions they might have about stuff. If you're security based and you like that sort of thing, then you're going to have a bit more of an interest in it than some of the other specialists on the team. Build and deploy. Just recorded a video about how that works in the team. On this channel, there's a playlist to do with each one of these areas. So if you want more detail, keep tuned for those. But build and deploy is all about building and testing and deploying the artifacts that the developers are creating and providing self-service for them. And I don't think I've missed anybody out, have I? Maybe developer support. In platform engineering specifically, we talk about golden paths. And this is where, sure, a developer can pick a language. I mean, they could pick Java or Python or Go or whatever. But it's often easier, especially from an organization point of view, that everyone follows a sort of a path or a template about when they create a new thing, so that they can get the best support. If everyone's using the same thing, then the same problems come back again, and so we can design documentation to avoid those problems and provide a golden path so that it's very easy for a developer to get from the drawing board to the web pages at the other end, the end service. And having a standard way of doing that makes it more efficient, quicker, and so you can go from idea to deployment very quickly if you've got a well-trodden path to follow, rather than trying to invent everything as you go. And so the development support is about providing signposts about what that path looks like, helping out with those templates and the guidance and things like that to make it really easy for the developers to do what they need to do and for them to see results really quickly. So once you've got all that, what do you do next? Well, like I said right at the beginning, IT contracting is then an option open to you. You've got a well-seasoned experience and you've got all of that knowledge. You want to be able to provide the best product, which you to platforms that need your help. And IT contracting is a way where you can provide your expertise and get a great return on your time for it. And I will support you through that journey as well. Support you, help you find a contract, interview assistance, out focusing on cash flow, is making sure you get paid and get paid what you're worth, and compliance. When you're a contractor, there's a load of other stuff that you need to work with, like accounting and billing and reporting, and so accounting is a big one. You work with accountants to make sure that that all gets done properly, and if you like, we can do a limited company done for you. We're based in the UK, so this is very much a UK focus on IT contracting, but we are there for you to help. So this is the areas that you can look at. And if I whiz right back to the start and look at the journey here: apprentice, 0 to 2 years, engineer, and then senior engineer. And with that, I'm going to close the stream. Hope you like the content. If you got this far, well done. Any comments in below, I'll read those later. Thanks for putting them in there. And I'll see you next time.